what extent we really focused on this in anatomy, but you'll notice here in the alveolus, there are what we call alveolar cells. And these are cells that line the alveolus. The ones that form the barrier are what are called type 1 alveolar cells. And they form, let's just say they help form the respiratory membrane. So along with the capillaries here, so this area right here, like that for example, that's the respiratory membrane. That's where we're doing gas exchange. Oxygen is coming this way, CO2 is coming that way. Okay. But you'll also notice that there are these specialized cells that are dispersed throughout some of the alveoli there. And these are called type 2 cells. And they don't participate in gas exchange. You'll notice that they have a lot of microvilli on them. That's to increase their surface area. They actually secrete substances. And what they secrete is something called surfactant. Have you heard of surfactant? Surfactant is basically a combination of lipids and proteins. It's really kind of like a detergent, for lack of a better way to describe it. But its purpose is it reduces surface tension of water. Okay, so that's what surfactant does, and we'll see why that's important here in a minute. It decreases surface tension of water. I'm going to comment on that. Okay. So structurally, in alveoli, we have some big alveoli, some little alveoli. You can see that on the picture. Some of them are of different sizes. We have type 1 alveolar cells that form a respiratory membrane with the pulmonary capillaries to allow for gas exchange. We have some type 2 specialized cells distributed throughout the alveoli that produce this surfactant. And that surfactant is important in changing the surface tension of water molecules that are lining the respiratory membrane. Remember, is water polar or non-polar?
Polar.
Very polar, right? So it's got the hydrogens on the water molecule. If that's my water molecule, because this is a polar covalent bond and oxygen is more electronegative than hydrogen, you're going to have a partially negative charge down here on the oxygen, and these hydrogens are going to be partially positive up here. Because of that, when you have multiple water molecules together, the negative ends of the oxygen of one will form a hydrogen bond with the positive charges on this hydrogen here. And this bond right here, that's what creates surface tension. That's why, actually, you may have done this in like, we used to do this in like, I don't know, maybe in elementary school or something, but if you take water and a very thin needle, the needle will actually, if you set it on top of the water, the needle will actually float on top of the water like a feather will float on water. The mass of the needle or feather is not sufficient enough to break those hydrogen bonds on that water film. Okay, and it'll float. If you add detergent to it, just like soap detergent from your sink to it, stir it up, that feather, maybe not the feather so much, but the needle will sink now. Because what is that detergent doing? It's interfering with these hydrogen bonds. So now the mass of that needle is enough to break those bonds of water. Now these are all fluid filled. Not fluid filled. That would not be good for you. They would be around. They're lined with fluid. They're moist, right? So because they have a moist, layer around them, surface tension will occur in those alveoli. And we'll see in a minute that has an impact on pressure within alveoli. So we want to make sure that we can kind of keep that in mind. So that's just some chemistry kinds of things there. Surfactant producing cells here, there. And they're not really, these surfactant producing cells are not really mature until about the time an infant is born. And that's simply because where's gas exchange occurring in a fetus? It's not happening in the lungs, right? So it's in the placenta, so they don't need them. But as soon as they're born, now gas exchange occurs in the air and they need to have these surfactant producing cells.